I guess you could just put not real. B is 2/9 because you just take the square root of both. Number 3, for this one, okay, we'll just do this one without a calculator. You guys remember how to do this by hand? Remember, if this one should come out nice, it's 4/3 of 7/29. This one should come out nice, but if they don't come out nice, you kind of have to do it by hand because the calculators can only do square roots. But any calculator could do this one, really. But if there's 4 of something in this breakdown, that comes out. If there's 4 of something. So 7 plus 2 plus 9 is 18. That means if 9 goes into 18, 9 goes into this. So 9 times 81. 9. Oh, maybe it doesn't break down nicely.
It does not.
It doesn't. Did I write the right thing down? Yes, I did. Did the book write the right thing down? Okay. So lots of 30s.
Is it gonna be
So
square root?
I think the book wrote the answer wrong now. Just a little bit wrong, not a lot wrong. No, okay, never mind, they didn't. Okay, 1, 2, 3, 4. Right? So if there's 4 of them, they get to come out as a normal 3. Okay, but there's a 9 left behind. So you put 4 through to 9 here.
That's
There's the 9 right there. The book did write that answer differently, but I'm not going to do it because it's too much to explain. B's negative 81. Is there a 4th root of a negative for B?
no.
Can you have a 4th root of a negative?
No.
Can 4 things of the same thing multiply together to get a negative?
No.
No. So B is just not real. So even powers, you can't multiply a number together even times and get a negative. It's impossible. But if you have an odd power, that would work. 3 negatives do equal a negative. Okay, for C, we should be able to do that without a calculator. 10,000, 4th root of 10,000. What times itself 4 times equals 10,000? What's 10 times 10? 100 times 10. 1,000. It just keeps adding a 0, right? So if it has 4 zeros in it, the 4th root would just be 10.
Look at that.
How do you do B1 2 because it's a decimal? What does that affect?
You can use your calculator, it's fine. The answer will be a decimal. It's kind of like the 3rd root of 27, but there will be a decimal in it. Okay, number 5. 3rd root of negative 72 x to the 5th. It's been a long time since we've done this, especially since we're gone for 2 weeks.
A long time.
3rd root of negative 72 x to the 5th. Okay, 72 doesn't have a cube root. Cassios can't do cube roots. So we gotta do this. Is it possible to have a cube root of a negative?
No.
Yes, it'll just be negative something.
Oh.
Let's put a negative out there. A negative times a negative times a negative equals a negative, so that's possible. Anyways, what goes into 72?
9 and 8. 3 and 3 and 2.
Kind of cheating here. Okay, so how does this go?
So 2 would be on the outside.
Right, we need a triple. So 2 cubed root of 9. So remember, we kind of left like a gap right there. because we gotta do the X's also.
Doesn't that subtract, I wanna say?
No, it's like division.
Oh,
What is 5 divided by 3?
1 with the remainder of 2.
1, yeah, with the remainder of 2. You guys remember this? So it's x to the 1 is on the outside, and x to the 2 is left inside. So that's it. Alright. 7. Alright, pretty much same thing. This is square root this time, so your calculator could help with the 27. 27, a to the 5th b. What goes into 27?
8. No,
9 times 3.
Mm-hmm.
9 is 3 times 3. So we're doing a square root. That means there's an invisible 2 right there. So it's 3 square root of 3. Okay, what about the a's? What's 5 divided by 2?
2.
2 with the remainder 1. So that means a to the 2 is on the outside. And just a is on the inside. What do we do with the b? Yeah, can't simplify it, so it just stays in square root. Number 9, cubed root of 0.125 x to the 4th y to the 6th. Now this is a cubed root. The calculator could help because the cubed root of 0.125 comes out perfectly. Do you guys know what the cubed root of 125 is? 5. So we do 0.5 times 0.5 times 0.5, it's still 125 with 3 decimal places. So it is 0.1. So anyway, it'll come out nicely. That's 0.5. Then what's 4 divided by 3? How many times 3 go into 4?
Once.
What's the remainder of?
1.
So 1, 1. What's 6 divided by 3 for the y's? 2. So it's 2 with the remainder of nothing. So that would be it. Convert each radical to exponential form. Gosh, so rusty on these. I don't know if we'll be ready. Will we be ready?
It's a lot of old stuff.
Yeah, it's been probably 4 weeks since we've done this. Sounds pretty bad, doesn't it?
Yeah.
before we do that one, let me back up a little bit. Do you guys remember what a rational number is? It's like fractions. We can write this, instead of using the radical form here, with this is the radical symbol, we can write it with just an exponent. You guys remember how it works?
Was it 3?
Yeah, it's a to the 2/3. So the power goes on top and the root goes on bottom. You could say this is 25 to the 1/4, but that probably wouldn't be simplified because 25 is a power of 5, right? So they would probably write it as 5 to the 2/4, and that reduces to 5 to the 1/2. Okay, and a to the what? 3/4. Yeah, if you remember what to do, these are pretty easy. B to the 2/4, which is 1/2. They call that exponential form, so everything's in the exponent. Okay. 12 is harder than 13.
Let's do 12.
Let's do 13 first. And then we'll talk about 12. So on 13, what is the root going to be for 13? 5. So you just put a fifth root up there like that. And then what am I going to put inside there?
5. And then x to the second.
X to the second and y, right? So their exponent, the top, just becomes their exponent. The bottom is their root. Okay, what's the problem on number 12 though?
We don't have the same one.
They don't have the same root. So do you guys remember how we fixed that?
Do you make them the denominator equal?
Yeah, we found a common denominator. So if you multiply 4/3 by 2, it would be 8/6. Okay, and then they would have the same, now they have the same root. So it's 2 to the 8th, well, it's the 6th root of 2 to the 8th and a. Go ahead and simplify 2 to the 8th. Like, you can plug in your calculator, but change that to a normal number. Alright, on 15 it says negative 64 to the 1/2. What did the 1/2 power actually mean? By the way, this would work in a calculator since there's no letters or anything. Huh? Right. 1/2 is like the square root. It's like 64 to the first power and the second root. So it's like the square root of 64, which is 8. Is the answer 8? It's -8. Why is it not an imaginary number?
I don't know.
The negative is not in parentheses, so the negative is not to the 1/2 power. Okay, if it said this, then we would have an imaginary number. But the negative is untouched by the square root, so it just stays out in front. Okay, on 17, so that's 25 to the third power and the second root. But when you work it out, you can just do the root first. That makes it easier. So what's the what's the square root of 25? 5. And what's 5 cubed? 125. So 17 would come out 125. Again, your calculator, if it's just numbers like this, your calculator can do it. But a lot of these are quicker if you know what you're doing. Anyway, 19 is not quicker. On 19, your calculator can't do it, but
I know,
it'll spit out a decimal.
it did spit out a decimal.
Your calculator can only do square roots, right? I'm talking about Casio's at this point, unless it comes out perfectly. And 19 does not come out perfectly. 16 to the 5/12. But what this means is, oh gosh, this is such a mess. They shouldn't have done this to us. It's 16 to the 5th, and it's the 12th root of that, right? 16 is a power of something. Yes, but there's something even smaller than that. 2. It's 2 times 2 is 4 times 2 is 8 times 2 is 16. It's 2 to the 4th. So here's what we're going to do. What's that? What do you do with the exponents here?
You can multiply.
Multiply. So it's 2 to the 20th. There's 22's multiplied together. We're not actually going to do that. So what we are going to do is 20 divided by 12. Like that. So how many times does 12 go into 20? 1. So there's 2 to the 1 on the outside. What's the remainder?
8.
Yeah, 8. Then you write it out. 1 with the remainder of 8. So you could say it's, 2 to 8 on this. This is kind of a nasty one. This is the pits, I guess. We could reduce this, and of course the book would. 8/12 reduces to 2/3. So we could have written it as 2 to the 1 on the outside, and to the 2/3 it would look like this. Whoops. Backwards. So they probably put a 4 right there then. Yeah, don't worry about that. I wouldn't put that on the test unless I made it a bonus, I guess. The others are fair game though. On 16, that is an imaginary answer, because the negative is in the square root. Go ahead and put the I on the answer. Don't write down just imaginary. Okay, 21. We're getting back into a little more familiar territory. 7 squared root of 18 minus 3 squared root of 2. Okay, do these go together? Okay, as they are written, they are not like terms. But, guess what?
We can change that.
Square root of 18 simplifies, right? And since these are square roots, that means Casio's can do them. They're cubed roots, no such luck. So 18 is 3 squared root of 2. So really this is 7 times 3 squared root of 2. 7 times 3 is 21. Square root of 2 minus 3 square root of 2. You guys remember how this works?
Mm-hmm.
It's kind of like 21x minus 3x is what? 18x. So this would just be 18 square root of 2. Let's go to how far? 25 maybe? Yeah, let's do 25 for today. That's over halfway, so that would be good, I think. We kind of need to move on. I mean, this is only. I still think we need to get the test done by Friday. All right. 23 is. Oh gosh, look at 24. Alright, 29 is not bad, 28 is not bad. Just 23 and 24 are a little bit nasty. What's the square root of x to the 4th on 23? I want to write that whole thing down and take me to them. What's the square root of x to the 4th? What times? Yeah. Do you guys remember how this works? Like if I had, let's say, cube root of x to the 12th, do you guys know what that would be? It's like 12 divided by 3, right? So it would be x to the 4th. So it's just divide. If it has a remainder, you got to break it up, right? Like we were doing earlier. So on 23, the square root of x to the 4th is like 4 divided by 2 is x squared. What's y to the 3rd? What's 3 divided by 2? Be 1 with the remainder of 1. And z would be like 1 divided by 2, so it's just a remainder of 1. So the z just stays put. Oh, I put a 3. There should be a 3 right there. Oops. So I haven't really looked at this problem yet, but I'm going to guess that they are all, they're all going to come out like that because you can only add and subtract like terms. So I'm guessing they're all going to come out. Somewhere to that. We'll see what happens. Okay, on the second term, what's the square root of x squared? X. And there's already an x on the outside, so x times x is x squared. The y and the square root of y do not simplify, so that's going to stay the same. And the square root of z does not simplify, so that stays the same. So are those two things like terms? Yes. Not only are they like terms, they're the exact same term. So basically we've got two of these things so far. This is one term, this one. I know it's not connected, but I can't squeeze it together on the smart board. Okay, anyways, the last one, plus 6. Okay, the square root of x squared is an x. It joins the x that's already on the outside and becomes x squared. The square root of y does not simplify. The square root of z does not simplify. Okay, is that a like term with the first two? Gosh, trick question. No. What's different? There's no y on the outside. So these two add together. This one doesn't because there wasn't any y right there. So I've got 2 of these plus 6 of these. So it's 2x squared y square root of yz plus 6x squared square root of yz. Good luck with 24. On 24, they are all like terms, so And, yeah. It's a tough one. It's a doozy. 25, this will be our last one for today. Kind of short and sweet, actually. Just like somebody didn't know how to put in a blank there. Who's short and sweet? Just like me.
I will need to confirm more than that.
Have not often been accused of being sweet. All right. 7 times 3 to the x minus 4 times 3 to x.
Does 3 to the x work like a variable?
Yeah. Yeah, so we have 7 of these things minus 4 of these things.
So just.
So you have 7 of something minus 3 of the same thing, then what do you have? 3 of those things. I said the wrong number. 7 of these minus 4 of these equals 3 of these. Okay, now here's the bonus round. Since these are both 3s, you can add their exponents together.
Oh, that's right.
So this is like 3 to the 1 plus x.
Look at that. Very nice. Very distinguished.
Lovely. There will be tears and gnashing of teeth when we do 23 in the other class. All right, why don't you guys try some of those evens today?